Hey, mid-module 4. You have this test on Friday and the following Tuesday because we don't have school December 18th. Remember, if you're watching this before Wednesday and Thursday, we have our Illuminate tests. These are very similar to our math tests, so it's important that you guys give these a try. Your test is going to look darn near identical to this. I hope that you guys follow directions. Good luck. So it says solve. Find your balance point. Step 2, distribute if needed. There is no distributing needed to be had. Combine all like terms on the same side. I cannot combine my coefficient with my constant. Can't do it. Combine variables on opposite sides. I only have one variable, so easy. Then combine constants on opposite sides. Aha! So I can add 7 to both sides. Negative 7 plus 7 is the additive inverse. That equals 0, which leaves me with just 5x. Negative 32 plus 7 leaves me with negative 25. Last step is isolate the variable using multiplication or division. 5x is multiplication. The inverse is division. I divide by 5. X then leaves me with negative 5 because 5 divided by 5 is 1x. You will need to show work on your test to receive full credit because we give partial credit. So make sure that you show the work in order to get some credit. From there, let's go to number 2, maybe. Okay. Oh, too much. There we go. Okay. My steps stay the same all the time. So step 1, find the balance point. Step 2, distribute if needed. There's no number smack dab up against the parentheses, therefore there's no distributing. Combine all like terms on the same side. 12x and negative 14. Coefficient with a variable, constant. Cannot combine them. Coefficient with a variable, constant. Cannot combine them. Step 4, combine variables on opposite sides. I've got 12x on my left, 3x on the right. My directions say combine variables on opposite sides using inverses of addition and subtraction. I'm only moving the variables using adding or subtracting. I personally have told my students to move the smaller variable. So 3 is smaller than 12. 3 is positive. The opposite of positive is negative. So I subtract 3x from both sides. 3x minus 3x is 0. Even though I'm subtracting, that's still the additive inverse. That leaves me 40 equals. This gives me 9x minus 14 equals 40. I add 14. Okay, hold on, I'm sorry. So I've just combined variables on opposite sides. The next step is combine constants on opposite sides. The goal is to isolate the variable. So in order to combine the constants, I need to move everything that I can away from the x. So this negative 14, we don't want on the side with the x. It's a constant because it doesn't have a variable. In order to move a constant, we use addition or subtraction. Well, it's already minus 14, so the opposite is positive 14. To keep it balanced, I do it on both sides. Negative 14 plus 14, again, additive inverse, that's 0. Leaves me with 9x equals 54. 54, because I got to keep up my street cred. From here, I divide both sides because the last step is to isolate the variable using multiplication or division. It's already multiplication, so we divide. That leaves me x equals, and that's going to be not 5 in this range, but 6. Okay? Let's see. Okay, number 3. Step 1, find the balance point. The balance point is always my equal sign. I prefer to find the balance point first so that I know when things are on one side or the other. That way I know I can combine on the same side or I'm combining on opposite sides. Coffee break. It's early and it's a Monday, so give me a second here. Number 3, we distribute. That's my second step. We distribute. So I'm distributing 3 to the 2x and 3 to the negative 6. Distribute means to multiply, not add, not subtract. 3 times 2x is 6x's. 3 times negative 6 is negative 18. I bring down the 3x because we didn't touch it. Equals 10x minus 6. Step 3 is combine like terms on the same side. Okay. So a couple different strategies. You can cover up one of the sides, which is why I now like having my dashed line. On the left-hand side, I have variables that are on the same side, 6x and 3x. When I have the same variable, I can combine those. So I subtract 6x's and I subtract positive 3x's. We include the sign with it. When they're on the same side, we do exactly what it says. 6 plus 3 is 9. We keep the variable. I did not touch negative 18. It comes down. Equals 10x minus 6. Okay. From here, step 4 is combine variables on opposite sides. Opposite sides. Left side, right side. 9x, 10x. The inverses are addition or subtraction. I personally will always move my smaller variable. 9 is smaller than 10. It's positive 9, so the inverse is subtract 9. 9 minus 9 is 0. That's still the added inverse. Please do not forget to bring down the negative with the 18. That leaves me 1x or just x minus 6. Most of you should know that 1x is the same as x. I like to just have that. Step 5 is combine constants on opposite sides. Again, move away from the x. So we add 6. It's good advice for real life too. Move away from the x. X equals, that gives me negative 12. Do I need to do anything with the x? Well, no, it's already isolated. So I get x equals negative 12. Move on. Okay, number 4. A little bit trickier. Balance point. Okay, so I'm going to use a lot of different colors to try to keep this organized. After the balance point, next step is to distribute. The number that's next to it is a negative 2. You must include the sign with the number. So 8x drops down. Negative 2 times 3x is negative 6x. Negative 2 times positive 4 is negative 8. 2x minus 7 minus 3x. Okay. Step 3, combine like terms on the same side. On the left-hand side, I have 8x's minus 6x's. That's 2x minus 8. On this right-hand side, I have a 2x and a negative 3x. So that's 2 minus 3, which is negative 1x. I did not touch the negative 7, so it comes down. Step 4, combine variables on opposite sides. 2x, negative 1x. In this case, my negative 1 is smaller. To move that to the other side, we do the inverse. We're only using adding and subtracting. It's already subtracting, so we're going to add. That comes down, so now I have negative 7. 3x minus 8 equals negative 7. Okay, combine constants. We want to move things away from the x. Negative 8, we're using the inverse of addition and subtraction. So I add 8. That leaves me with 0 there, so 3x equals 1. Last but not least, isolate the variable by multiplying or dividing. Well, in this case, we divide. That leaves me with x equals 1/3. Mrs. Blair's students, I don't know if she accepts decimals. Mr. H's kids, you know that if you give me a decimal, I'm marking it wrong. Always give me a simplified fraction. So we get x equals 1/3. You cannot simplify that anymore. Okay. Moving on. Let's see. Okay, Elizabeth paid $7.50 for 5 pounds of coffee. Assuming each pound of coffee costs the same amount, complete the table of values representing the cost of coffee in pounds. So one of the first lessons that I taught my kids was saying, okay, let's go back to 7th grade. We found a constant. Our constant back in 7th grade was y divided by x equals k, because it's a proportional relationship. That's what this is. So we are doing y divided by x to get us our constant. So if I do 750 divided by 5, 7.50 divided by 5, I get a constant of $1.50. That means 1 pound costs $1.50. Well, how am I going to do everything else? Well, now I can say y equals 150x, because the only thing that we need is that constant. My kiddos, I taught you that very first day that it was y equals mx, because constants, if you remember from lesson 15, is a slope. So now I can plug in 2. 2 times 150 is $3. 3 times 150 is $4.50. 4 times 150 should be $6. And then 6 times 150 should be $9. Okay? Now I'm going to come over here and I'm going to kind of make some things because I know the next question I think is asking me to graph. So my ordered pairs are 1, 150, 2, 3, 3, 4.5, 4, 6, 5, 7, and 50, and 6, 9. Okay, so now I've got some ordered pairs. Let's see what the next question says. Yep. Whoa, okay, that's not what I wanted to do. Perfect. Love when that happens. It says graph the data on a coordinate plane, and you have a coordinate plane on your paper. So, 1, 2, 3, 4, 5, 6. And this is pounds, and this is cost. And then I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to go 1 up 150, 2 up 3, 3 up 4.5, 4 up 6, 5 up 750, and 6 up 9. And if you notice, my graph is linear, or it should be linear, because we have a constant, which is my slope. Okay? Now, do I want you to use a dash? No, I'd like you to use this arrow here. Okay? Connect that and go from there, because you can buy 1.25 pounds. Okay? Let's erase this. So all I did was I made ordered pairs from the original question, from question A, and then I graphed them. Okay, on the same day, Elizabeth's friend Becky was charged $9 for 5.5 pounds of coffee. Explain in terms of the graph why this can't be true. Well, if you saw your graph, which was going like this, this point here was 6 pounds for $9. If she wanted 5.5 pounds, does that meet at $9? You would say 5.5 pounds does not have a cost of $9 based off of our graph. So again, you would say if I have 5.5 pounds of coffee, it does not give me $9 for the cost. Good luck on your test, guys. If you have any questions, please make sure you ask myself or Miss Blair. Have a wonderful, safe day. Maybe if I can find to shut it off. There we go.